Hello, everyone. Welcome and thank you for joining us today. Today's webinar is a part of our Deep Dive Enterprise Manager webcast series. Our topic today, validating database performance before committing updates, upgrades, and migrations. I have with me today Alfredo Krieg. He's a Principal Security Management Specialist, and he's been with us before. We've got some recordings in the series from Alfredo. He's also a great blogger. You can go to Alfredo Krieg DBA, his blog. My name is Tim Mooney, Product Marketing Director, and this is part of our Enterprise Manager webcast series. You can see the link on the bottom. You'll see more scheduled events coming up, as well as recordings if you missed any. Take a second to read our safe harbor statement. And here's our program agenda. I'll quickly turn it over to Alfredo to do an Enterprise Manager overview. Then he'll do a deep dive on real application testing, the concept, as well as a demonstration so you see firsthand how to use these tools. I'll wrap with a little bit about the business value of using real application testing based on some research. And then we'll have some dedicated time for Q&A. We'll share some resources at the end. Throughout this entire session, we have experts online. Use that Q&A tab down at the bottom. We're going to answer all your questions in real time. If we run out of time, we'll follow up with you. So this is a great chance for you to take advantage of those resources, and really appreciate your participation on that. So with that, I think I'm ready to turn it over to you, Alfredo.
Thanks, Tim. Let's start by quickly reviewing all the available database management packs. Keep in mind that Oracle's Enterprise Manager-based functionality can be further extended by adding one or more of these packs, which include diagnostics and tuning, real application testing, which is the pack that we're going to be reviewing today, lifecycle management pack, cloud management pack, and data masking and subsetting. Inside Oracle Real Application Testing, we have 4 available tools. The first one is the Consolidation Workbench. We have the SQL Performance Analyzer, and we call it SPA. We have Database Replay, and also we have SPA Quick Check. We're going to be reviewing each of them individually in the next slides. First of all, let's discuss about how we do interact with real application testing. We have 2 options. The first one is, of course, to use the Oracle command lines APIs. That means that I can connect to the database, and I have an example at the bottom of the screen where I have an Oracle database release 18, and I make use of the package DBMS SQL PA. In this example, I'm creating an analysis task, and you can see that I can make use of the command line interface in order to interact with real application testing. On the other side, I have Oracle Enterprise Manager, and under quality management, you can see that I have the database replay menu or SQL Performance Analyzer menu. Let's start with Database Consolidation Workbench. Oracle Consolidation Workbench helps you consolidate to Oracle Private or Public Cloud or to Oracle Exadata. What it does is it will accurately estimate all the required resources for migration. So basically, we have an advisor that is going to be running using all the available AWR data for the source databases. It will estimate all the required resources for the workload that you are migrating to either the Oracle Private, the Public Cloud, or to Oracle Exadata. It makes use of high availability options to minimize downtime. This is, of course, subject to source and destination database platform and version. And currently, Database Consolidation Workbench supports two consolidation scenarios. These consolidation scenarios either work for single instance or for rack databases. The first scenario involves having the source databases consolidated into fewer destination databases. The second scenario means that all the source databases are going to be consolidated into fewer servers. At the end, you get the same number of databases. We have three main steps on the database consolidation workbench. The first one is to plan. On the plan phase, Oracle Consolidation Workbench will give you consolidation advice. It will identify all those candidate databases for that designated consolidation platform. Everything is based using AWR data. At the end, you get an estimate of all the requirements needed for that consolidation project. On the second phase, the migrate phase, the database consolidation workbench is going to implement the consolidation plan by migrating databases to the new consolidation platform. This is by using all the Oracle's Enterprise Manager provisioning features. Last but not least, we have the validate step. On the validate step, database consolidation workbench will make use of the real application testing SPA, and in the background is going to be running test workloads on those consolidated databases and reporting back those results. Here I'm showing the database selection option inside the database consolidation workbench dashboard. You can see I have several tabs on the screen. So I have the general tab, the source candidates, source workload, destination candidates, and the advisor findings. Inside the source candidates tab, I have all the available information inside the table. As you can see, I have 6 source candidates for that consolidation destination platform. I have all the databases on the left side, the CPU capacity, memory, allocated storage, used storage. Then I have information about I/O usage, either requests per second or megabytes per second, database version, and operating system. Moving forward to the second tool, we have SQL Performance Analyzer, or SPA. SPA helps you to predict the impact of system changes on SQL workload. So any system changes related to the optimizer makes sense to use SQL Performance Analyzer. So the first step is to capture the SQL workload into SQL tuning sets. After that, the second step is to build different SQL trials or experiments for these SQL statements. And basically what we do is we test the execution or we get the explain plan of these SQL statements. So one useful thing here is that you can capture SQL statements into SQL tuning sets on production, then transfer these SQL tuning sets to a test system where you can have more freedom of running these experiments, right? Do the test execution of these SQL statements and then start making changes to this test system based on the needs, right? And after that, run a post-change trial and compare and get the results. So we transfer that to a test system, then we make a change, then we execute the post-change trial, then we compare SQL performance and we get an analysis report. As you can see, SQL Performance Analyzer, SPA, is seamlessly integrated with SQL tuning sets, with SQL plan baselines, and also SQL tuning advisor to form an end-to-end solution. That means that in the analysis report, any reported SQL that had regression after the change you are going to be allowed to create SQL tuning sets for those specific SQLs that regressed, and then call either SPM or SQL Tuning Advisor to find a recommendation on the solution for those suboptimal plans. Okay, so in the guided workflow, we have several steps. The first one, of course, is to capture SQL tuning sets. We capture SQL tuning sets from production. We get all the workload inside the SQL tuning sets, and then we have several options here. You either transfer those SQL tuning sets to a test system, which is the recommendation here, or you leave them on that system if you are able to make changes on that system. Then we run a pre-change trial on the system. Here, there are several options as well. The first one is to execute those SQL statements and gather all the execution statistics. Or the second one is just to gather the explain plan, right? Then the next step is to make the change, the actual change to the system if you're modifying a parameter in the database, or you are adding a Nexadata storage server, or you are getting rid of an instance in a node, you name it, right? Then we run a post-change trial in the system. Then we compare the SQL performance of that post-change trial against the pre-change trial. We get an analysis and we get reports. Then we implement the tuning recommendations that come from the report. We implement either SPM or the recommendations coming from SQL Tuning Advisor. And then if we feel comfortable with the SQL statements, we complete the test. If not, we can go back and execute another post-change trial, compare the performance again, until we feel satisfied with the output of the report coming from SQL Performance Analyzer. If I click on the guided workflow, I will have to go through 5 main steps. The first one, of course, is to create the SQL Performance Analyzer task, right? That is based on a SQL tuning set that was already captured. Then we executed the pre-change trial in the initial environment. Then we make a change on that environment. We execute the post-change trial in the changed environment. Then on step number 4, we're going to be comparing step 2 and 3, which are the post-change and the pre-change trial. Then on step number 5, what we do is we view the trial comparison report and we take actions based on that report. So on step number 4, when we're comparing step 2 and 3, we're going to be able to select the pre-change trial and the post-change trial. And then we have some comparison metrics. I expanded that combo box where you can see all the available options for comparison metrics. We have elapsed time. You can compare based on CPU time, user I/O time, buffer gets, physical I/Os, optimizer cost, or I/O interconnect bytes if you're running on real application clusters, right? Then you have the option to schedule that immediately or run that comparison later on based on the inputs from the screen. Once you run the analyzer report, this is how it looks like. We have the name of the analyzer task report on the top of the screen. It's giving you information about the SQL tuning set that was used, the owner, the total number of SQL statements, the SQL statements with errors. That means that a SQL Performance Analyzer was not able to execute those SQL statements. The name of the SQL Trial 1, the name of the SQL Trial 2, and the comparison metric. In this case, is elapsed time. In the middle of the screen, we have those global statistics where we're showing a graph of the elapsed time in seconds for the SQL Trial 1 and the SQL Trial 2. We see the improvement impact in percentage. In this example is 7%. And also we can see the regression impact, which is 62%, right? The overall impact of this change is 55% of regression. Then on the bottom of the screen, we're showing you the top 10 SQLs based on impact on the workload. The SQL IDs marked with a red arrow means that we have regression. And of course, the ones with the green arrow are improvement. Then if we keep looking at the table that we have, we can see the net impact on the workload in percentage, the elapsed time before and after, and the net impact on SQL performance. At the end of the table, we can see if there was a new plan or not. Then on the recommendation section, you can see that I highlighted inside the red box. You have the option to run the SQL tuning advisor for those particular SQLs, or create a SQL tuning set, and later on you can either run SPM to find and log an optimal plan for those particular SQLs. So before even trying to run database replay, we recommend to execute SPA. SPA is going to increase your database replay confidence. And the idea is to identify that regrets SQL in the test system before even attempting to run a database replay. So that takes us to the third tool, which is database replay. And I want to highlight the differences between SPA and database replay. When you capture SQLs inside a SQL tuning set in order to execute a SQL Performance Analyzer or SPA, and then you ask SPA to test execute the SQL statements, SPA is just going to go serially with no particular order and execute the SQL statements. But what happens if you have the requirement of capturing production workload and replay into a test system exactly the same way as the workload happened in the production system? What that means is you're trying to keep all these production workload characteristics, such as timing, transaction dependency, think time, and transfer them, maintain them, and replay them into a test system. Then we make use of database replay. Basically, we capture production workloads, we transfer them into a test system, we process this capture into a test system, we set up replay clients, and then we replay the capture maintaining all these characteristics. At the end, we analyze and report back on the results of this. We can test and measure transaction throughput improvements. We can identify application scalability and concurrency problems on this test system before we even deploy this in production. We can also perform capacity planning, and also we can execute consolidated replay with multi-tenant or schema consolidation scenarios. Okay, so there are several prereqs and recommendations before even attempting to execute database replay. As we mentioned, we have SPA, but you have to know your application. There is no detailed knowledge required, but you need to know a couple of characteristics of your application. The first one is you want to know all the distinct workloads that you're trying to capture. Where the peak time of those workloads, if there are any optimizer changes during login, such as logon triggers, where you set, for example, alter session and you set the optimizer mode to first rows 10. And of course, you need to know about some workload capture restrictions. For example, we have some restrictions on distributed transactions. We have all the restrictions inside our 19C testing guide. I recommend to take a look at the testing guide documentation for additional information on these capture restrictions. You want to know when database backups or batch jobs are running, right? For example, DBMS scheduler jobs that they're running in your application. Then the second step is to capture your workload. Again, as we mentioned, we recommend to execute SPA. You want to capture all distinct workloads into separate SQL tuning sets, and then also capture SQL tuning sets from a time period before cloning the database, right? When you clone the database, then all those SQL tuning sets are already transferred to your clone or your test system. On the database replay side, our recommendation is to identify again these time periods where the critical workload is being executed. Peak time, batch jobs, and time of, about critical activity in your database. Then another recommendation is to start the capture in a quiet period so you can start ramping up your capturing, right? And last but not least, make sure that you have enough space for the capture. When we're capturing using database replay, we offload all those capture files into a directory, right? So you want to make sure that you have enough space to accommodate all those files. Inside Oracle Enterprise Manager, we have the database replay menu, and this is the dashboard that we have. You capture the workload, you copy or move the workload to a test environment, we process the workload, we set up replay clients, we replay the workload, and we have the analysis and reporting task. There are two tabs here. The first one is the capture workloads. I have an example of a test capture here. The status is completed. The owner is Sysman, the creation date. We have the database name, database version, and also we have a tab specifically for the replay tasks. When you finish that capture, you see here that if you click on the capture, we have this database replay screen where we provide detailed information about the source workload. We have the name of the capture, the storage host, database name, database version, and the active session graph of that particular capture. If you click on subsets from the previous screen, you are able to subset that particular capture. That means let's say in this example, I capture 8 minutes of the workload from production, but I just want to replay 3 minutes out of those 8 minutes that I captured, right? That means that you have the ability using Oracle Enterprise Manager to subset this particular capture and just replay that subset, that small part of the capture into a test system, okay? Then if I click on the name of the database capture, I can see the summary information of the capture. I have the name of the replay capture job and the status, in this case, succeeded, the database target, database name, version, DB ID, if there were any errors in the capture, the data size of the capture, and then I have the start SCN and the end SCN. This is key because when you clone your production system in order to set up the test system, you want to make sure that you're going to be cloning your database to that particular start SCN. That means you want to have the test system exactly at the same time when you started the capture. So when you execute the database replay, you are comparing apples to apples. You don't want to have data diversion because in the capture, the SQL statements, for example, we're selecting 8 rows or updating 9 rows. And then when you clone the database, those tables have different amount of rows. And instead of updating those number of rows, they're updating different number of rows. Then on the replay transaction settings. So the first question that we get is, do I need to restart the database? The answer is no, but it's a good recommendation that we give to our customers. Keep in mind that any in-flight sessions that are happening in the database are in general not a problem, but you have to look for sessions that change the optimizer during login. We already discussed that in previous slides. Or batch jobs that run for hours, right? Run learning transactions can affect the database replay. or maintenance windows, there is some interference, right? So how you avoid it? First, try to start capturing in a quiet period. And then, if needed, try to use the capture subsetting option that I already showed you. On the synchronization side, for database replay, we have two main options. The first one is to use time, okay? And this is the default and recommended. What it happens is when you're capturing SQL statements, we are also capturing the timestamp when that particular SQL was captured. When we replay and you select the time synchronization mode, we're going to be releasing those SQL statements by using that timestamp we capture. So let's say we capture 10 SQL statements and in that particular order, then based on the timestamp where they were captured, we're going to be releasing them into a test system. Okay. The second option that we have is to use SCM. And basically what we do is instead of honoring the timestamp when they were captured, we're going to be honoring the commit and the transaction dependency of that particular SQL. There are different characteristics of each of them. For time, if you find a load divergence, we recommend to stick to it. And you have additional options if you use time. So this is the only option that we have if you want to make a stress testing, okay? With modifying settings like think time scale or connect time scale. If you use SEN, try to stick to it only when there is a lot of high divergence with the previous synchronization mode that was time. And use it when you have high transaction dependency. Try to make sure that all statements are tuned before the replay when you use SEM. That means try to use SPA first. And if you're aware that there is a regression, keep in mind that the database replay time will take much longer using SEN than using time. Moving forward to database replay modes. We have two main replay modes. The first one is query mode only. And this is only available if you select the time synchronization mode. Database replay query only mode will omit any DML, DDL, and PL/SQL packages. Keep in mind that query regression is the #1 reason for slow replay. If you select query only mode, there's going to be no synchronization, no locking. It would highlight slow SQL, and this can be repeated, and there is no need to restore database because you are not modifying any data in the test system, and it will keep all statistics for easy comparison. So now the next step is to move to read-write only after you executed query only mode. The recommendation is to execute and progress to read-write only when you have the same or shorter elapsed time or the same or shorter DB time. Okay, database read-write mode, it helps with get the information for functional analysis at the end of the replay. So that is going to help you investigate errors, data divergence, if it is a small percentage of overall calls. And keep in mind that you're trying to target this database replay in read-write mode for 80 to 90% of successful user calls, right? Then you have questions like, well, is this divergence that is identified limited to only few objects or schemas? Can this divergence be ignored if there are any background jobs or long-running jobs as we saw in previous slides? Or if this belongs to non-critical business flows. If you have high divergence, this usually points to test system setup incorrectly, like missing objects, or remember that we were discussing about the start SCN for the clone. And try to use application metrics for validation on this functional analysis. Using Oracle Enterprise Manager, we have the option to replay. So in this case, when I go and I click on replay, we select the target. In this case, it's a database version 19.3. And then you have a different task list for pre-process the workload, deploy replay clients, and replay workload, right? At the end, you get a summary report of the replay when it's showing if the status is in progress or it completed. You have whole flexibility to stop the replay. Also, you get an overview summary of the current replay, the elapsed time. You get the timing of the capture and the replay. Detailed comparison between the capture and the replay based on duration, database time, the number of active sessions, user calls. And last but not least, you get the divergence report at the end of the replay. Moving forward to the last tool, we have SPA Quick Check. So we discussed about SQL Performance Analyzer and how SQL Performance Analyzer can help you identify regression on SQL statements before and after making changes on test systems, right? Then you can transfer that to your production systems when you make those changes. For production systems though, we want to spend a couple of minutes here discussing SPA Quick Check. So you have your production database and you have some pre-selected SQL tuning sets, and also you get some settings for SQL Performance Analyzer. SPA Quick Check, keep in mind that is an optimized tool. That means that it's optimized for use on production systems. Okay. You have the optimal trial or explain plan mode, and we disable multi executions, and full DBML execute is disabled. This is in order to protect your production system, right? It is control. You have control on the per SQL time limit, and also the testing is scoped to a private session, right? You can associate this with resource consumer groups, and it's also change aware. What that means is all the SQL Performance Quick Check is context aware of the change testing workload. So for example, we have some workflows for optimize or gather statistics or for init.aura parameter changes. As I mentioned, it's optimized. We have the optimal trial mode and there is no DML execute. You can control this and modify the scope of the SQL Quick Check, SPA Quick Check. Again, scope by time limits, limits this testing scope to a private session, and it's change aware. So basically, we use SPA Quick Check. Let me give you a quick example. When you run SQL Tuning Advisor and SQL Tuning Advisor is giving you a recommendation to create a SQL profile, most of the times what we do is we go ahead and implement the SQL profile, and then we go back to the SQL statistics screen for that particular SQL ID, and we're staring at the screen, waiting to see that the execution plan changed, and then we're crossing our fingers, hoping that the new plan that is generated is better than the old one, right? So with SPA Quick Check, you eliminate all this guessing work that we do as database administrators, and instead of waiting and staring at the screen and looking for graphs and the statistics of the new SQL plan that is generated, SPA Quick Check will gather information before the change, execute and create a SQL profile for you, and gather information after the SQL profile was created. It will generate a report for you and let you know exactly if the outcome of that SQL profile is the one that you're expecting or not. So basically you eliminate all that guesswork. So now let's move forward to our demo about SQL Performance Analyzer and real application testing. Okay, this is my demo environment. I went to target databases and I can see all the databases in this demo environment. As you can see, I have the sales.oracle.com, testoracle.com, and upgr.oracle.com. Along with their versions, sales.oracle.com is a database running on 18.3, I have test.oracle.com that is running on 18.6, and I have this UPGR that is running on 19.3 version. Let me expand the pluggable databases for sales.oracle.com, and I'll click on the P-Sales pluggable database. Okay. So I'll navigate to Performance, SQL, and SQL tuning sets. On this database, I want to show you how do we capture SQL statements into SQL tuning sets. Remember that this is a prereq for SQL Performance Analyzer, right? We need to capture workload, store all the SQL statements along with the SQL statistics and execution statistics into a SQL tuning set. So I already capture some workload for this P-Sales container early on, right? If you want to start capturing a new SQL tuning set, you will click on Create and then just define the time period or the duration of the capture, right? Then click Next, and Oracle Enterprise Manager is going to start capturing everything for you. What I want to show you here is how to transfer this SQL tuning set from the sales.oracle.com to the UPGR database, right? That is running on a 19.3 version. I'll select this SQL tuning set. I'll click on Copy to a database. Then I have the Copy SQL tuning set web page. I'll select the destination database. In this case, I want to send it to the P-Sales pluggable database under the UPGR container. Click Select. Then I need to define or choose an existing directory that exists on both the sales.oracle.com and the target, which is the 19.3 database. Next, I need to define and set the credentials. I'll choose this name credential for the host. Destination host is the same host where I have those two databases. And then destination credential here. I'll select system, right? Then it's asking me for some job parameters, a job name, a description, and then the schedule. You can run it immediately or running later. You can say one time later or repeating if you want to transfer this SQL tuning set periodically to the target database, for example, every day at 1 a.m. in the that'll work. I'll click OK. And the copy job was successfully created, right? I can see the job details. But right now, I'm gonna jump right away into my test.oracle.com database. Let me expand this as well, expand the pluggable databases and click on P-Sales. Then I will navigate through Performance, SQL Performance Analyzer home, right? And I'll click on Guided Workflow. The first step of the guided workflow involves creating the SQL Performance Analyzer task based on a SQL tuning set. I'll click on Execute. I'll put a name here, Test SPA Demo Task, right? Description, SPA Demo Task. And then it's asking me for the SQL tuning set. I have the P-Sales STS that we just transferred. Click on Select, right? Then click Create. The task was successfully created. We can see the status. Then the second step is to create the pre-change trial in this initial environment. Let me click on Execute. And then is giving me a SQL trial name by default. Just gonna leave that. And then on creation method, I have several options. So during the presentation, I explained that we have the option to execute those SQL statements locally. You have also the option to execute those SQL statements remotely. You have the option that instead of executing SQLs, you can just generate SQL plans, all the execution plans. You have two options, locally or remotely. Or last but not least, build this SQL trial based on the information that we're carrying over from the SQL training set. In this example, because I captured that SQL training set from production, I want to make use of all those statistics from the sales.oracle.com database. So I'll select build from SQL training set. I don't want SQL Performance Analyzer to re-execute those SQLs. And in the schedule, I'll select immediately. And then on the right side, Oracle Enterprise Manager is giving me some guidelines for this trial environment. Okay. I'll click on trial environment established. Basically, it's telling you that if you execute SQLs, they're going to be actually running the SQL statements. Okay. And giving you some guidance about this trial environment, right? Click submit. It's gonna take a couple of seconds because it's not gonna execute anything, right? Okay, it completed. Then the next step is to execute the post change trial. As you can see, this test.oracle.com database is already running on 18.6. What I did previously this morning was to patch this database from 18.3 to 18.6, and basically that is the change that I want to test. I want to get the trial and the experiments, and basically trying to predict what is gonna change based on the optimizer that was patched from 18.3 to 18.6 based on the workload that I had in production. I want to see how this workload behaves on 18.6. I'll click on execute. In this case, yes, I want those SQLs to be executed locally, right? I can define the scope and the time limit. You have the option to say, well, limit that for 5 minutes for each SQL statement, unlimited, or customize that. Just select 5 minutes. The schedule is going to be immediately, and I need to select here that the trial and environment was established. Click on submit. This one is going to take a little bit longer than step number 2 because, in fact, is executing those SQL statements. SQL Performance Analyzer is going to grab those 180 plus SQL statements that it has, and it's going to be executing them serially in no particular order. It's just going to be executing them, grabbing execution plans and execution statistics, and storing everything inside PA. It finished. So now it's time to compare step number 2 and step 3. Click on execute. And as I showed you on the presentation, we have several options for this comparison metric. I can select elapsed time. We can compare by CPU time, IO time, buffer get. Let me select buffer get in this example. The schedule is going to be immediately, and I'll click submit. Oracle Enterprise Manager is instructing SPA to compare step 2, which is the pre-change trial, against step 3, which is the post-change trial. It completed. Now it's time to view the comparison report. And this is the comparison report. We see that on the upper side of the screen, we have information related to the SQL tuning set, the name, the owner, and the number of SQL statements, the name and information about the SQL trials and the comparison metric. Then we have in the middle of the screen a graph that is giving you all the global statistics, right? We have SQL trial 1, SQL trial 2. We see that we don't have any improvement. In fact, we have 170% of regression. Okay. At the bottom of the screen, we have 4 SQL statements, all of them with regression, responsible for this 170%. The first one, which is 6KD, has a 167% impact on this regression. And the number of buffer gets before compared to the number of buffer gets after it's really different, right? There's no new plan for that. And then we have several recommendations here. The first one is to create SQL plan baselines and basically calling SPM, right? Then the second option is to execute SQL tuning advisor or create a SQL tuning set that is just going to contain these 4 SQL statements that had regression. Okay, really explanatory report with all the options available to fix these SQL statements. But now let me jump into the second scenario that we have. What happens if we have this workload from the sales.oracle.com database running on 19.3 and we decide to upgrade the database to 19.3? How that workload is going to behave on 19.3? Let me click on P-Sales. Right, we already confirmed that we have the SQL tuning set here. And same thing, I'll click on SQL Performance Analyzer home, click on guided workflow, start the task, test SPA demo task, SPA demo task. Select our P-Sales STS that contains all our SQL statements. Click Create. I'm going to click on Execute. And same thing, because I'm transferring everything from production, I just want to build this trial based on what I have inside the SQL tuning set. Click on Trial and Environment Establish. Click Submit. Refresh, completed. The next step is to make the change to our environment, which we already did, is running on 19.3 version. And we want to assess the impact of this change against our workload. Let me click on Execute. I'm going to execute the SQLs locally, 5 minutes. Click on Trial and Environment Establish and click Submit. Let's wait couple of seconds here till SPA executes these SQL statements that are inside our SQL tuning set. Okay, we see that the status change now is executing. Let me refresh. It's still executing. And it completed. Now it's time to compare. Let me click on Execute. And same thing, I want to compare using buffer gets. I want to compare apples to apples with the previous experiment we did from 18.3 to 18.6, right? Click Submit. It completed, and now it's time to review the report. So what we have here in the report, we have a regression impact of 35%. So it's completely different than the previous report that we got from 18.3 to 18.6. There are still a couple of SQL statements though that had regression. We see the 6KD, which is the same one that we saw as the top offender on the previous exercise, and this second SQL ID. We can see that the first one is the one that is having that 35% impact. So if we fix this SQL statement, we're probably gonna fix most of our issues going from 18.3 and patching to 18.6, or going from 18.3 and upgrading to 19.3. We see that there is no plan, and we see the difference in buffer gets before and after. The options that we have from the recommendations section is to run SQL Tuning Advisor or create a SQL Tuning set. So as you see, SQL Performance Analyzer is a great tool to assess how our workload is going to behave when we introduce changes to our system. If either we want to patch, we want to upgrade databases, we can assess that impact in the performance of our workload, right? It's really critical to know how the workload from production is going to behave on tasks such as patching and upgrade, but also works for things like changing a parameter setting in our database. What about the impact of gathering statistics in a different way, right? So it's a really powerful tool, and it's another option for database administrators to reduce risks related to production, application, and databases when it gets into performance and changes for those systems. This concludes our presentation and demo, and now it's time to go back to you, Tim.
All right, Alfredo, thank you very much. That's fantastic. I always appreciate those demos. Great presentation, so thank you for that. So this reminded me of your last recording, the last webinar we did together, where you covered the diagnostics and tuning pack. You also did mention real application testing there as well. So the beauty, again, of Enterprise Manager is that all these pieces are integrated together, enabling DBAs to seamlessly go through their workflow, whether it's finding problems, fixing them, validating them, pushing them to production, and making sure everything works well. So that's great. And next, in summary, when do you want to use validation performance with real application testing? We talked about sort of three areas or three scenarios: migration, consolidation in general. You're moving workloads either to the cloud or to another on-premises environment. Use real application testing. Verify everything works exactly as you hoped and expected. See what kind of performance you're going to get. Actually get as much utilization out of your infrastructure as possible by leveraging the consolidation workbench. Next, you have performance management. We talked about that in the previous slide. Identifying problems, fixing them, validating them before you push them live. Anywhere, whether it's in your on-prem or cloud environments. And lastly, adoption of new features of the database or upgrading to newest release of the database. All these things can be validated using real application testing to make sure your business can stay on the latest technology at the lowest possible risk and get there quicker. So take advantage of real application testing to make your companies more agile. Lastly, I wanted to point out some business benefits here down in the lower right-hand corner. 224% ROI. This was a study done by Forrester. We've had it for a while. So this is a report that was done a while ago. But they're showing 224% return on investment over 3 years with a payback on investment in less than 6 months. So pretty impressive. So let me break down the benefits here. Just in summary, the biggest benefit from implementing real application testing by those that were interviewed by Forrester, it was a number of our customers where they did some really deep dive interviews and survey questions to get their information. They found that about 2/3 of the benefit was improvements in productivity for DBAs. Yeah, DBAs were much more efficient, much more effective, leveraging real application testing. The next was around higher revenue generation. Honestly, that was a super small sliver of the ROI. I'm really glad about that too, because you never know if you can gain that kind of revenue with increases in performance or availability. It's always a benefit to get those results, but in an ROI analysis, that's hard to actually forecast. So the last part of the ROI where they showed the big benefit was around efficiency and effectiveness of using the infrastructure you have. So just higher utilization of your cloud properties, higher utilization of your on-premise technology. That was about 1/3 of the ROI. So big benefit to DBAs, much more efficient and effective. Also savings in regards to needing less infrastructure. So at the same time, you're getting better performance, better availability, and that weighs in as well, but largely it's those other very tangible results. Okay, let's jump into Q&A. Use that tab at the bottom of your screen. We will answer all your questions in real time. We have experts on the line supporting that. We've got Alfredo here. I'm going to share some resources while we're doing that. So please ask your questions. If we can't get to them all, I see a bunch of them coming in. We will follow up with you quickly. So just a few resources. We've been talking about the Enterprise Manager webcast series. There's the link. We will have workshops shortly. So we have some new environments. We have some new demos that we will walk you through in a workshop. And I'm going to get those live on the calendar shortly. All of these, most of these webcasts, I've also got a blog. So you can see a little description. You can see recordings of these webinars. You can also download the presentation there. I see some people asking for that. I'm also going to try and post a copy of the demo that Alfredo did. So you'll find that there. And lastly, we have additional resources on oracle.com. There's Enterprise Manager, Real Application Testing. You'll find white papers and other resources. The testing guide is a really nice guide, detailed how-to on using real application testing. Then a couple other documents there and resources. And then on the bottom, we have our social. So we've got a big following on Twitter, Oracle_MGMT. I talked about the blogs, and then something we need to talk about a little more is our YouTube channel, Oracle Management Cloud. So take a look there. You'll find a bunch of demonstrations, customer testimonials, business analysis, and other videos there. So take a look there. And thank you all for joining today. And happy testing.